The solubility of a substance is how many grams of that solute we can dissolve in a litre of water. So the common unit that we see being used and we find in a lot of data tables and online is how many grams per litre. However, with what we're going to be looking at here today, which is another way to quickly know if something's highly soluble or not, a thing called the KS or solubility product, we actually need to know this solubility in moles per litre first for this value to be meaningful. I'm going to use an example of a sparingly soluble salt called calcium hydroxide, commonly called lime water, to show that. And what we often find when we work with lime water is that in our solution we've got some solids sitting on the bottom. That's because lime water itself, the solution sitting on top, is best used as a saturated solution. That means I can't put any more calcium hydroxide in there and it will dissolve. It just will settle out at the bottom. What's really happening down here though, at this interface where the solid meets the solution, what's really happening is this equilibrium here, where the rate of the forward reaction is equivalent to the rate of the reverse reaction. So as calcium hydroxide dissolves, at the same rate, particles of calcium ions and hydroxide ions are reforming as the solid. So that's what's happening at the interface. So I can draw an equilibrium equation for this. So as it's got an equilibrium equation, I can write an equilibrium expression for it. And here I'm just going to ask that you remember from last year how we do this. So my K for this, and I call it Ks because it's a dissolving equation, so solubility, is equal to the concentration of the calcium ions times the hydroxide ions, and because there's two of them, I write it twice. Well, anything times itself is that value squared. And you'll notice that the little 2 there is the 2 in front. So if that was 3, this would be cubed, and so on. Now I don't put it over calcium hydroxide, the solid, because it is a solid. So it's not over anything at all. Alright, so we only look at the things that are dissolved in the water. So aqueous, our aqueous species, in this case they're both ions. So to work this out, to work out what the Ks value of calcium hydroxide is, I need to know some information. I could look at the concentration of the hydroxide ions, and then using this balanced equation, that would give me the concentration of my calcium ions. So I could do that using pH. And from that, I could just plug those numbers in here, and it will give me the Ks value. I could look up, or I could measure how much solid I was able to dissolve in a given volume, and use this relationship here to work out how many moles per litre it is, and then plug those numbers in. So there's a few ways that I could actually do this. What I do find though is that the value for this is very, very small. It is, and please excuse me while I quickly check if I've recorded this, 4.68 times 10 to the negative 6. Now this is a tiny number. It's about a millionth of one. So what that is telling me is that this is not very soluble at all. The bigger the Ks value is, the more this reaction goes in the forward direction, which means the more dissolves. So this is a tiny number. This tells me that this is not very soluble at all. I can actually work out how soluble it is by going backwards. If I look at this value here, then I can actually say how soluble it is. If I look at this balanced equation, and I call the solubility of calcium hydroxide S in moles per litre. There's S moles per litre of calcium ions, and there are 2S moles per litre of hydroxide ions. I know this because the 2 is in front of it. So therefore, if I plugged that into this expression here as algebra, I get that this value here, 4.68 times 10 to the negative 6, is equal to S times 2S squared. You'll notice I've used the brackets, which is equal to S times 4S squared, which is 4S cubed. Well, my algebra is good enough to solve that, so I'm going to divide this number by 4 and this number by 4, press equals on my calculator, and then I'm going to take the cube root of it to find s. So, in other words, s cubed is going to equal 4.68 times 10 to the negative 6 over 4. I'm going to put it in brackets just to make sure I don't make any silly mistakes there. So bear with me while I do that on my calculator. Okay, so this number here is 1.17 times 10 to the negative 6. And then s is going to be the cube root of this value. Which is 0.0105, and my unit here is moles per litre. So that's the solubility of calcium hydroxide. I think you'd agree that's a very, very tiny number. Now it's not very meaningful to me, so I actually need to get it into grams per litre to be a meaningful value as well. So here I've got moles per litre, and I want to go back to grams per litre. So using this relationship here, I'm multiplying by its molar mass. So assuming that it's not got any water of crystallization in the original salt that I'm going to make it from, then I can do that quite easily. Sorry for going up here, but we're going to take that value, 0.0105 moles per litre. We're going to multiply it by its molar mass, and that the molar mass for calcium hydroxide is 74.1. So 74.1 grams per mole will give this to me in grams per litre. And I get 0.780 grams per litre. Again, not much, less than a gram in every litre. So when I have got solubility, I can be given it as grams per litre or moles per litre and be asked to calculate the Ks value. I do that just by plugging the values in after I've got my Ks expression. Alternatively, I could be given the Ks value and asked to find the solubility in moles per litre and or grams per litre. For that, I need to do a bit of algebra where I say S is the solubility, so I look at this. So for every one of those, it makes one of those and two of those. Plug those numbers into my Ks expression, which is what this one here is called, my Ks expression. And then I'm given the little algebraic expression that I have to solve. So here it was that this value here equals 4s cubed, so I solved for s. Those are the only two things that you need to be able to do with solubility. It's a relationship between Ks and solubility. The larger Ks is, the more soluble a salt is. The smaller Ks, the more insoluble a salt is, or the more sparingly soluble it is.